14. Question number 22. Starting from rest, an object rolls down along an incline that rises by 3 in every 5 along it. The object gains a speed of root 10 meter per second as it travels a distance of 5 by 3 meter along the incline. What can be the possible shape of the object? Here, given. So before writing this solution, we write first given. Starting from rest, an object rolls down along an incline that rises by 3 meters. 3 in every 5 along it. Okay. Now, here we consider, suppose this is the incline. This is the incline. Okay. Suppose this angle is theta. Then we can write here it rises 3 in every 5. It rises 3 in every 5. That means if this is 5, then this is 3. If this is 5, then this much is 3. And therefore we write here sin theta is equal to 3 by 5. We have given sin theta is equal to 3 by 5. That means if this is equal to height h and this is equal to s, then we get here 3 by 5 is equal to h upon s. Also, we have given gains a speed of root 10 meter per second. We write here v is equal to root 10 meter per second. Now, if we consider the sin theta equal to 3 by 5 is equal to h upon s, and therefore we get here that is it travels a distance of 5 by 3. That body travels a distance of 5 by 3. Therefore, I write here s is equal to 5 by 3. This is also given. And we have to obtain the possible shape of the body. Possible shape. What is the possible shape? Okay. Now, suppose we solve this. We know this relation. Whenever body travels along an incline, then we know the relation v equal to root 2gh upon 1 plus k square upon r square. You know this formula. Now we put the values here. V equal to, we write root 10 is equal to root 2g root 2g then h is equal to here s sin theta, and s equal to 5 by 3. I will write here 5 by 3 into sin theta is equal to 3 by 5 upon 1 plus k square upon r square. Now we square both sides. Therefore 10 is equal to only 2g, because these cancels with each other, 2g upon 1 plus k square upon r square. Now 1 plus k square upon r square is equal to this side 2 into 9.8 divided by 10, or we can write here 1 plus k square upon r square is equal to 2 into 9.8 means 2 into 10. I will write 20 upon 10, and therefore 1 plus k square upon r square is equal to 2, and therefore k square upon r square is equal to 1. Now you know I equal to mk square for any body, and I equal to mr square for ring or hollow cylinder, hollow sphere. Okay, hollow sphere. Now if we compare this, then I upon I, suppose we can we compare these two equations, then I upon I is equal to k square upon r square, and we have got this. Therefore body must be ring or hollow sphere. Here we complete our first topic, that is rotational dynamics. Now we will see some key points for CET. Key points are some basic formulas for CET. See here, first thing, instantaneous acceleration. A is equal to, you can write omega square r, which is equal to v square upon r. This is first formula. Then second, centripetal force is equal to F is equal to m omega square r, which is equal to mv square upon r, and same is the centrifugal force, but only directions are different. Then turning of cyclist on curved road. When cyclists take a turn on a curved road, then he bends with angle theta, given by theta is equal to tan inverse v square upon rg. This is another formula. Now fourth point, for unbanked road, Vmax is equal to root mu rg. Fifth point, for banked road, here we consider for banked road friction absent. Then Vmax is equal to root rg tan theta, and here we consider banking absent. Okay, banking absent, only unbanking or friction. Here friction absent, Vmax is equal to root rg tan theta. These are the 5 formulas. We see one by one. Now sixth point, we consider here motion in a vertical circle. In that TL minus TH equal to 6 mg. Also VL equal to root 5 rg. Then VH is equal to root rg, and Vm is equal to root 3 rg. That means suppose you consider this is the circle, this is the lowest point, this is the highest point, and this is the middle points, and particle moves in an anti-clockwise sense like that. These are the formulas. Then seventh, conical pendulum. For conical pendulum, T equal to 2 pi root h upon g is equal to 2 pi root L cos theta upon g. Now mass tied to rod. VL equal to lowest point. VL equal to 2 root rg. Vm equal to root 2 rg. These are the velocities. Now mass tied to a rod. Now one formula remain here. Ninth, I will say here. For banked road with friction Vmax is equal to square root mu plus tan theta upon 1 minus mu tan theta into gr. This is ninth formula. Now next 10th. I equal to mr square. This is the moment of inertia. Radius of gyration k is equal to, suppose k is the radius of gyration, which is equal to root I upon m. This is mi. Now 12th. xcm is equal to summation mx upon m. ycm is equal to summation my upon m, and zcm is equal to summation mz upon m. These all formula for non-rigid body. Now 13. Suppose I will write in the same heading. xcm is equal to 1 upon m integration of x dm. ycm is equal to 1 upon m integration of y dm, and zcm is equal to 1 upon m integration of z dm for rigid body. Okay. Now 13. mi of ring. First, in that transverse axis means, you remember, passing through center and perpendicular to its plane length, like that. I equal to mr square. Second one, in this, about diameter, I is equal to 1/2 mr square. Third, any tangent as axis of rotation, I is equal to 3/5 to mr square. Now same here. mi of disc, same thing. 1, transverse, perpendicular to plane and passing through center. I is equal to 1/2 mr square. Then second, about diameter as axis of rotation, I equal to 1/4 mr square. And third one, any tangent, I equal to 3/4 mr square. Now thin uniform rod. Point number 15. Thin uniform rod. First, transverse means passing through center and perpendicular to length, transverse axis. I is equal to ml square upon 12. Second one, one end, axis passing through one end. I is equal to ml square upon 3. Now 16 point, rectangular sheet transverse axis. I is equal to m l square plus b square upon 12. Point number 17, we consider solid cylinder, transverse axis. I is equal to m l square upon 12 plus r square upon 4. And about vertical axis, just like a disk, we write I is equal to m r square upon 4. And here consider solid sphere, solid sphere. Any diameter we consider here, means we consider transverse axis. I is equal to 2 by 5 mr square. 2 by 5 mr square. Point number 19. Hollow sphere. Hollow sphere. Diameter as axis of rotation. Then I is equal to 2 by 3 mr square. And next one, tangent. I is equal to 5 by 3 mr square. Now point number 20. Circular disc of inner radius r1 and outer radius r2. Means like this here. Suppose this is the disc, like this, This is a disc having inner radius as r1 and outer as r2. Here, this is r1 and total, suppose this is r2. Then I is equal to 1/2 m r1 square plus r2 square. Now point number 21. Point number 21. Here, hollow cylinder of inner radius r1 and outer radius r2. First, about transverse axis, I is equal to m. Here we write m. Again, m into bracket r1 square plus r2 square upon 4 plus l square upon 12. And about own axis, I is equal to 1/2 m r1 square plus r2 square. Now point number 22. Angular momentum, L bar is equal to R bar cross P bar. L is equal to PR is equal to MVR is equal to MR square omega, which is equal to I omega. 23. Kinetic energy, rotational, 1/2 I omega square is equal to L square upon 2I. Also, point number 24, torque is equal to dl by dt. Point number 25, kinetic energy, rolling is equal to Ke translational plus Ke rotational. You put all the values depending on. Now, for inclined plane for rolling body, V equal to square root 2gh 1 plus k square upon r square, and acceleration A is equal to g sin theta upon 1 plus k square upon r square. This is all about rotational dynamics. Now you prepare yourself for exam dated on 28th of this month, 28th of June. Best luck, good luck, thank you.